Welcome back. This is Joel, and in this video we will talk about cloud security. Right? We'll concentrate on mainly the SaaS version of cloud. Right? So and then obviously we'll look into the solution, Cisco's solution for SaaS cloud security as well, which is Cloudlock. Right? But before that, let's get some context around this. So let me just quickly go down to my drawing board here. Right? All right, so so like I said, just to mention it again over here, we are going to talk about just SaaS in this one, right? We are not going to concentrate on the other two versions. I think you guys probably know about infrastructure as a service as a platform as a service, right? So those two, let's park it for a minute. Let's talk about SaaS, right? Now, what's the thing, or what's the situation with SaaS, right? So the problem with SaaS is you have, this is think of this as a cloud, right? Terrible drawing, but yeah, think of this as cloud, and you have your SaaS apps here, right? Let's use different colors. Maybe there is one app which is, say, Office 365, and then probably there's one more app, Slack, right? Or maybe there is one more which is WebEx, right? So you have different cloud-based applications residing here on the cloud. And you have people accessing it from everywhere, right? You have people accessing from, say, here, which is, let's call this as a remote, right? Remote users. Then you've got people accessing it from the corporate, right? Headquarters, right? And then you probably have people accessing it from the branch office, right? So you have different, because it's cloud-based apps, you have people accessing it from everywhere, right? Now, I think these both, if you look at these both, which is headquarters and the branch, right? These are generally secured, right? What I mean by that is the access, right? When you're accessing a cloud app from, from the headquarters, it generally passes through some kind of a firewall here, right? Similarly, most of the branches have a firewall here as well, right? Or sometimes, the branch officers, they backhaul, all the traffic to the headquarters, and then, the traffic goes out to the internet or to the cloud. Now, in that case, whenever you have a firewall in the path, right, you're safe, because I wouldn't say you're completely safe, because you can never achieve like 100% security, but to some extent, you can put in your corporate policies over here, right? You can enforce it, right? But the problem is here, right? When I'm saying remote, right, basically means that the users are anywhere in the world, right? People probably are working from home, like right now, where most of us are really working from home. And we might be, connecting to the apps from literally from, any place all over the world, right? So it's very difficult in such a situation, right, to enforce some kind of security policies, because literally there's nothing in the path. You're not going through headquarters, you're not going through branch office, you're directly going from the internet and connecting to the apps, right? So now this basically means we have to think of some really out of the box ideas here to kind of make sure that we kind of secure this kind of act. All right, so that secret sauce which you really need in case of a SaaS based security, right, I would kind of break it down into three important aspects, right? What are those three aspects? First one is behavior analytics. I'm gonna just write it as behavior here, right? Behavior analytics. Second one would be DLP, right? Data loss protection, prevention, whatnot, right? I think it's prevention, data loss prevention, right? And the third one would be application-based firewalls. And I explain what these constitute, right? What they actually mean. So let's look at behavior, right? And again, think in terms of SaaS, right? We are talking about SaaS, right? So your security strategy might be different when you're talking about other clouds, architectures, which is, PaaS or IaaS, right? But for SaaS, this is what we are talking about here. All right. Now, talking about the first one, which is the behavior, right? So think of this example, right? You've got your network here, right? And you have a legitimate user connecting here, right? And say the user is connecting to the network, he or she is providing some legitimate, username and password, right? Because of which you're allowing that person to connect to the network, right? And depending on that person's need, they are going to probably download some file, right? Upload some file, do whatever, right? That's how people access the network and do their jobs. But now imagine there is a bad person who also is connecting to the network, right? And let's say he has brute forced the user credentials, or he has hijacked a session, whatnot, right? And he has gotten access to the network as well. He's also going to provide the same username password, and he's also going to get access to the network, right? But then in case of the hacker, he's probably not going to simply go and browse the file. He's probably going to do something bad, right? Maybe he's going to he's going to probably upload a malware, right? Or he's going to probably do a lateral move, right? From this particular system, he's probably going to move to a another system which has higher privilege or something like that, right? So obviously you can't predict what the hackers are going to do, right? But then imagine this is a scenario. Now in this case, if I ask you, how would you differentiate, right? How would you kind of build a system which is resilient, which is which can figure out which can figure out who is legitimate user, authorized user, and who is not, right? So you can't really do that with just the information which I gave you, right? What you're missing here is you're missing one important piece. What is it? The context. So you're missing the context, right? And context is very important, because if I can give you some little more information, right? If I can give you the information that okay, the users are coming from which country, right? What is the IP address, right? And what is the time when the access is being done, right? Or from which operating system are they trying to access? So I'm just giving you some information here that will give you some kind of a context, right? So that will help you understand if this person is coming, is he a legitimate user, right? Because let's say your company is based out of, I don't know, maybe your enterprise is based out of say India, right? And suddenly if you observe an IP which is belonging to say something from Russia or China, right? You can quickly understand that there is something happening, unless the person has really traveled to that country, getting an access request from a completely different IP block, it kind of means that there is something wrong happening, right? So okay, so that is something which is very important when you talk about the SaaS security, right? And you would really need a product which can give you this behavior analytics, right, to make more informed and better decisions, because now based on this context you can write policies to do accordingly, right, to quarantine a particular user and so on, right? So hope that clears out what is behavior analytics. Let me clear this. The second, all right, so we'll talk about DLP next, right, which is data loss prevention, right? Now what is DLP? Again, let me draw a small example here. So imagine you are like sitting down here, right? You're probably on a laptop, right? And you're connected to your network, right? You're probably corporate network, something like this, right? With your enterprise network, whatnot, right? So this is your network. And then you've got, from there, imagine, I don't know, maybe you have some kind of a, this is the internet, right? Think of this as the internet. Now what you're doing is, imagine you're working for a financial organization, right? You're working for a financial organization, or something which deals with, or maybe something which deals with personal information, right? Social security numbers or telephone numbers and so on, right? So you're working on some kind of a project, and by mistake or even knowingly, unknowingly, different people do it, right? So you kind of downloaded a list of, I don't know, credit card numbers here, right? Imagine you did that, right? You downloaded some kind of credit card numbers of the users, or some personal information, right? When I say personal information, it could be usernames, it could be passwords, whatnot, right? And you download it, and say you're a bad person and you want to leak this information outside, right? And you want to send it to someone in the internet, right? What you would do is probably you'd probably create an email, right? You would create an email, probably send this as an attachment, right? Directly to the outside world, to the internet, because this is the internet, right? So you're sending it to some kind of a server or some kind of a database, right? Something, or to some other peer-to-peer email to one of your friend or whatever, right? Now this is really serious. This is really bad, because you have leaked the information, the personal information, right? And the document, whatever you have attached and you have sent it, has that information, account numbers or credit card numbers or usernames, passwords, right? So we really need some kind of a mechanism, because again, think of SaaS, right? This is literally something which can happen on a everyday basis, right? Knowingly, unknowingly, it can happen in a SaaS environment, because you have people accessing these resources on their personal laptops, on their phones, right, or even on their corporate laptops. But they are accessing all of this, right? They are using Office 365, they are using financial apps and so on, right? So they might download some very important information, and then they might share it to the outside internet, right? So data loss prevention kind of prevents this, right? Data loss prevention is basically, think of it, bunch of solutions that address this challenge, right? Where authorized users are doing some unauthorized stuff, right? Which is, they are taking the data, moving the data, right, outside of authorized regions, I would say, right? So that is another very important aspect, and the SaaS security should address that, correct? Now the other one, the last part, is the application firewall, right? So application firewall, let me just again get rid of this. Yeah, so imagine this scenario, right? When we talk about application firewalls, imagine this. So you are sitting here on your laptop, right? So this is inside your organization, or maybe you're remotely working, whatnot, right? And then you've got this huge network. What is this network? Right, bunch of routers and whatnot, right? Load balancers and huge things. So this is your internet, right? And then finally you have your cloud application sitting here, right? This is your cloud app. So when you're sitting here and you're trying to access your cloud app, what is happening is there are a bunch of attack surfaces, right? But it's very important on your strategy. So where do you want to kind of deploy your security? Do you want to do it here, or do you want to do it here, or do you want to do it here? Now I would say personally, doing it here is of no use, because this is the internet, right? You can't enforce anything over here, right? You will always have, right, you'll always have to fear for the worst, which is billions of threats, right? You're going to have a lot of threats here. What is under your control is mainly this side, and probably this one, maybe doing some endpoint security and stuff on the client side. But since we are talking mainly on the cloud security, we'll just concentrate on this one, right? So this area, or this is this particular section, which is the cloud application, right? This is where you can deploy some security. And firewalls, when you talk about firewalls, right, maybe in this area over here, what kind of firewall do you think will work? Right, because say your application is running on some port, say port 800, right? Just give me an example, right? Or TCP port 800. You will have to keep that port 800, and you'll have to allow IPs from all over the world to access that particular port, right? You can't put up access lists allowing access only from one IP or something, because it's a cloud app. You will have people connecting it from all over the place, all over the country, all over the world, right? So you'll have to allow access, you'll have to keep those ports open, right? So but then the only tool or weapon which you have here is what we call as the application firewall, because you will have to look at layer beyond layer 3, right? And you'll have to because at the end of the day, what are the possible attacks here? Malware attack is a very possible attack. Malware is, at the end of the day, is also an application, right? Malware in the truest form is an application. So it's basically nothing but, at the end of the day, an application that performs undesired malicious actions, right? So you need a firewall which can identify that for you, right? You need a firewall that can monitor how the data is exchanged, right, between your application and other entities. Maybe there is a database here, right? Or maybe there are some other kind of entity. So you need some kind of a firewall here which can look at the application patterns, right? Application data patterns, and kind of raise policy violations, right? So that's why having a normal layer 3 firewall is of no use. Rather, you'll have to work with a application firewall at this particular layer. So that's basically my 3 important pillars of I would say of your cloud security, SaaS mainly. All right, so now we can talk about CASB, right? So let me just write that and try to explain. All right, so CASB, right, or it's basically nothing but cloud access, right? Security, B for broker, right? Don't confuse this to be some name of a product, right? This is not a product. This is a generic, industry term, right? Cloud access security broker, right? And I think the name itself is very self-explanatory. It is doing some kind of a intermediate work, right? Intermediary work between the user and the cloud app, right? So so yeah, so why do we need this cloud CASB, right? I think we have kind of covered that, right? Because we realize that there are certain aspects which are very much needed to ensure SaaS cloud security, which is behavior analytics, DLP, application firewall, right? All of this, and we realize that these are some of the features which your traditional cloud environment can't provide, right? Your traditional SaaS app, right, doesn't provide, right? Or even if maybe some of them might provide and not everyone provides. So but then these three features, in fact there are many other features as well, but these three are very critical, and you really need these three features to be consistent, and you need these features to ensure or enforce security policies, right? And CASB basically allows you and to provide that, right? So imagine, if you look at the architecture of CASB, right, think of it as, imagine how cool it will be, right, if you have like one single dashboard, right? One single dashboard, where you can manage your access to all these various apps, right? You have Office 365, WebEx, and maybe Slack, and whatnot, right? You have like, say, hundreds of applications, Splunk, and so many SaaS applications, right? Imagine if you have one single dashboard where you can manage, right, one single dashboard for an organization, right? Say your company is called x.com, right? And so for one particular organization, you might be using the services of multiple hundreds of different SaaS applications. So imagine if you can have one single dashboard, right, where you can manage the security policies, manage who can access these applications, manage who can kind of upload data to a particular application, right, or upload a file, right, or who can probably connect to it, or different applications serve different purposes, right? So imagine if you have single pane of glass to manage the security perspective of all these SaaS applications. That's literally what CASB achieves, right? Now again, there are different again, like I said, we are talking mainly about Cisco's solution here in the next section, but there are different architectures for CASB as well, right? So if I have to probably show that, so there are, if you talk about CASB, there are mainly two deployments which you normally see, right? You have, one is called inline, and the other one is called obviously out of band, and I'm gonna say OOB, right? So you've got inline deployment and out of band. So what is inline, right? In inline, you basically have the, let's use a different color. Let's say this is the user, right? This is the user, and this is the cloud app, right? And what is there in between? Obviously the cloud app. So you have the internet, right? Something like this. Okay. So inline, we are talking about inline. So inline, what happens is you generally have some kind of a proxy, right, over here, right? You have a forward proxy, right, where it basically proxies all the user requests, right, coming towards that cloud application. And then you have the CASB, or the CASB's intelligence basically sits as a cloud application or on a data center somewhere here, right? Let's call this as a security service or something, right? So you basically have a architecture of this sort. So all the requests first come to the proxy, and then the forward proxy will forward it to the engine, and the engine will then take the decision, okay, based on the security policies. Okay, the request is coming from, say, India, right, for this particular application. Should I allow it, right? Or the request is coming with the user wants to upload a particular file. Do you think the file has some kind of malware? All of the decisions are taken here, and then the access is given, right? So that's forward proxy. Very similar to this, again, under the inline, we have one more thing called as reverse proxy, right? So for that, the difference is that what is going to happen is, let me just get rid of this. In case of reverse proxy, the proxy will sit very close to the cloud application, right? It will be over here. This is a reverse proxy, right? So in that case, the user will first make the connection, right? all the connections which basically come, right, they will think of this as a load balancer kind of situation, right? The connections will directly hit the reverse proxy. The reverse proxy will then talk to the engine, and then the final decision is made, and then the access is given, right? So there are just two different variations. In forward proxy, you have the proxy sitting closer to the user. In reverse proxy, the proxy is sitting closer to the cloud application. But in both of these, what is happening is the the CASB is kind of like in the data path. That's why it is called inline, right? Which means that if there is some issue with the CASB, if there is some issue with the proxy, then your whole access to the cloud application can get blocked, right? Which is not really good, right? So to get away with this, there have been some new designs, right, for CASB. New architectures have come up, and that's basically your second one, which is your OOB design. All right, so in OOB, what happens is that you still have your user here, right, and you have the cloud application here sitting right on the internet, obviously. So you have the internet over here, right? Think of this as the internet. But in this case, this is out of band. So what happens is the user directly accesses the cloud application, right? The CASB will not sit in the data path, right? It is nowhere in between. The CASB will sit somewhere outside, right? That's why you call it as a out of band, right? So it will basically sit here, and you still have that engine which I talked about, right? The intelligence engine, the security policies, and all of that. So think of this as security policy engine. So that also will be there. Now, in out of band, again, you have two versions. One is generally called as the API version, another one is the log version, right? Again, like I'm saying, I'm just explaining the various architectures which are available in the market, right, which are provided by different vendors, right? Some people do it while using APIs, some people do it using logs, right? What I mean by API is, think of it this way: you're the user and you're trying to access, say, Office 365 application, right? So imagine with the API, this is how it works, right? So the Office 365 application will quickly send out API request to your CASB, over here, out of band CASB, right? And it will say, look, I'm getting a request from a particular user, right? And this out of band CASB will then quickly check with its engine, right, which is like a centralized engine, and it will check, okay, is this user allowed to access? And then if the engine says yes, then that information is relayed back, and the CASB will then reply back saying, look, yeah, you can allow that user to connect. That is with the API. So all of that communication happens using APIs. With a log-based approach, it's kind of little slower, because what happens is in log-based, whenever a request comes, you need some kind of a tool, right? Basically, this particular CASB will just monitor that log engine. So every time that log is created, right, then he's going to check with the the security intelligence engine, and then it's going to provide. It's basically the flow is still the same. Only difference is the communication will generally not happen using APIs. Rather, it is going to happen by scraping through the logs, right, which is kind of slower when compared to APIs, right? So that those are different architectures out there for CASB, right? Now you understand why we need CASB, especially in a SaaS, security model, and what are the two different architectures. One is inline, one is out of band, right? You call it out of band because it is not in the path, of the data traffic, right? The CASB sits completely away in a completely parallel different path. So now that we know the generic term, industry term, and we know the generic architecture, now let's look at Cisco's CASB, right? Cisco's solution. The Cisco's solution, right? The CASB solution from Cisco is basically called as Cloudlock, right? I believe of late it has been bundled as part of Umbrella. So if you see the documentation, you'll basically find it under docs.umbrella.com/Cloudlock dash documentation, right? And you'll find all the information you need on how to create your policies, how to use the app firewall, how to use the behavior analytics, and all the latest release notes and all of that, right? So all of that information you can find here, right? That being said, let's get back to my whiteboard just so that we can continue the discussion, right? So let's get back to the whiteboard, and probably let's get rid of this. So your like I said, CASB is Cisco's cloud. Cloudlock is Cisco's CASB. But then what kind of a CASB it is, right? Because we discussed inline, out of band, right? So Cloudlock, let me just write it here. So Cloudlock is nothing but it's a out of band, right? It's an out of band API based CASB, right? We talked about what is the API based, right? Wherein your cloud applications and your CASB, they basically talk via APIs, right? They don't wait for scraping the logs, right? So that's why it's a API based. So it's a Cloudlock is nothing but it's a CASB, but what kind of a CASB? It's a out of band API based CASB, right? Which means your user experience is going to be you will not even feel like, as a user, you will not even feel that there is a CASB in place, right? Your experience of using the cloud application will not depend on anything with the CASB, because it's a completely out of band, right? It's not inline. So even if your CASB is down, I mean the whole the proxy, you don't have the concept of forward proxy, reverse proxy, anything. It's a API based. And most of these APIs, right, the whole API integration between the CASB and the SaaS applications, they are generally built with the vendors, with the public cloud vendors, right, in collaboration, co-developed with the public cloud vendors. So as a result, all of them are very nice. There's nice synergy as well, right? So that being said, and how it's actually, I mean, personally, if I have to say, it's like you can set it up within like within 5 minutes. It's that simple to set it up. I mean, think of it this way, right? You are one of the admin. You are an admin for say a particular company called X.com, right? This is your company, and you are the IT guy. You are the admin, and you are tasked with setting up the CASB solution for your company, right? And say you are using, say, Google, right? You are using Google for everything. You are a Google shop, right? Which means you're using Google for email. You're using Google for you're using the Google's SaaS video application. You're using Google's calendar, whatnot, right? Let's say you're using all Google SaaS products in your organization, right? So how do you employ CASB here? What you'll have to do is you'll have to go to your admin console, right? Being an admin, you will have an admin console in your Google SaaS console. You'll have to go there, and you'll have to just grant CASB all the required permissions, right? So that you are basically offloading all the security related activities to the CASB to take care, right? And you can like peacefully sit and let CASB do the magic, right? So we'll look at the dashboard and we'll talk a little bit more on that later. But now to talk about some of the core capabilities of CASB, right? I mean Cloudlock. From now on, whenever I refer CASB, I'm talking about Cloudlock, because I'm talking about the Cisco solution, right? So some of the important things would be, first thing, so I'm again going to think of some of the most important use cases which I have come across. One is securing, securing what? Securing users. Right? One example here is, think of it this way. So you're accessing an application, say in US, right? USA, right? Say probably in some state in USA, right? You're accessing an application, say Slack, right? You're accessing from there, right? And CASB records it because CASB has visibility into it, right? And within 1 hour, right, you also get someone tries to access the same application using the same credentials, say from India, right? So CASB has this common intelligence to figure out that, look, that same user couldn't have traveled to India in just 1 hour, right? So obviously this person who is trying to access the same application from a different country altogether and so far away, it clearly means that it's a compromised user, right? So it has policies to detect that. So that's pretty cool. So that's the first use case, which is securing the users. Second thing is, I would say, securing the cloud data, right? Securing the data, right? The data, and for data we talked about this DLP, right? So that basically comes into play. Again, a use case would be something like this. Imagine a bunch of people are working on a project, right? And say one of the engineer takes one of that important document and uploads it to, say, Dropbox, right? What is Dropbox? Dropbox is a public repository, right? It's a public storage repository. And imagine this document has some very important credentials. It has some customer ID, account number, whatnot, right? So CASB can look at this. CASB has the intelligence to, you can define that you can define a policy to go and check if did a user publish a document to Dropbox, and did that document have some secret information, that did it have some credit card numbers, did it have some financial information, did it have some customer data, right? So you can define some policies and you can prevent this data leakage, right? You can prevent this data from leaking from your SaaS application onto some kind of a public repository like Dropbox or box.com, right? So that's the next cool feature as well. Okay, next, the third thing which third one would be you have secured your users, you have secured your data. Now I would want to go and secure my application itself, my cloud app, right? So how would I do that? Using Cloudlock, right? So think of this use case. Say you're a user, right, and you're trying to enable a OAuth connection, right, from, I don't know, maybe think this is yourself, right? This is your laptop, and this is, say, Google, right? And say this is some random application, right? Let's use red color here. This is some random application, right, which is asking you permission. So it's basically trying to authenticate, or it's trying to use OAuth over here, right? I'll explain what OAuth is in the very next section, but you would have seen this quite often, right? When you're trying to access some music application like Spotify and stuff like that, you have these options to log in with Facebook, log in with Google, right? Log in with Twitter or whatnot, right? So you have all this OAuth based applications, right? Wherein some random third-party application will be trying to use your Google authentication, right? And when you do that, right, Google is going to give you a small pop-up saying that, look, this third-party application wants these permissions. Do you want me to provide it, right? So there are a lot of such attacks, right? OAuth attacks, where some random exploit kind of an application, it will try to mimic a legitimate application, right? So this application might look like it is some legitimate application. Maybe it might appear as if it is like Google Drive, or it might appear as Google Images, but it is not legitimate application, right? And they will get all the permissions of your Google account, and then it can harvest information and do a lot of bad things with your account, right? So CASB has the intelligence to figure out and kind of block such applications, and kind of restrict such applications from using OAuth and connecting to your actual account, right? So that's pretty good as well. In addition to that, there are a lot of other, like I've just listed down 3 important features here, but there are some of the other few things on the top of my mind. Is you can do encryption as well, which is again something like, imagine Cloudlock detected that you have uploaded a file to Dropbox, right? Very similar to that use case which I was explaining earlier, right? It can immediately go and encrypt that data, right? Which means no one will be able to kind of use that information, or access that information, even though it is there in the public cloud, right? So it can quickly, while the data before uploading the data to Dropbox, it can quickly go and encrypt it, right? So it has all of that cool intelligence, right? But I just listed down top 3 of my favorite features here, but there are a lot of other stuff as well. All right. So one piece which I want to talk here before we jump on and look at the Cloudlock dashboard is authentication piece of it, right? So since we're talking mainly about SaaS security, it becomes very important to talk about authentication in your SaaS applications, right? And the protocol which is generally used. Now, cloud applications, the very important issue is the scale, right? You're going to have users from all over the world connecting to it, right? You'll have remote, you'll have people from the corporate network, and managed users, managed network, unmanaged devices, and so a lot of permutations and combinations. So you have a lot of users coming in. One of the solution that is used to scale your SaaS identity management is what they call as OAuth. Now, what is OAuth? OAuth is a protocol, just like any other. It's a protocol. It's a open standard, actually, open authorization protocol, right, which allows access to application environments. But the cool thing here is, with this protocol, you really don't have to share your login credentials. That's the cool thing about this, right? So in your OAuth, it's a protocol, right? Like I said, you have a certain components, right? So you think of this way. So you have your user right over here who wants to probably access some kind of a music app, right? So let's use a green Spotify. Let's use green color, right? Maybe like a music app, right? So he wants to connect to a music app and he wants to probably play some music. So he wants to log into the music app, but the music app doesn't have its own authentication database and all of that, because that is not its main job, right? Music app's main job is to provide playlists or whatever. So it hasn't implemented its own authentication, so it can use OAuth, right, to authenticate the user using some existing resource providers, right? What are the resource providers? So this is the resource providers. So in resource providers, you have a lot of these guys. You have Google, you have Facebook, you have Okta, and many other resource providers, right? So this is how the whole workflow goes through, right? So the user tries to access the music app, and the music app will now send an authentication request. Let's use a blue color here, right? It will send an authentication request, right, to the resource provider. And when I say it sends authentication request, it basically also gives a small pop-up here in your app, right? This is your laptop, so when you're accessing the application, here you'll get the pop-up, right? So that pop-up will basically be of the resource provider. So if you're using Google as your resource provider, you're going to get a pop-up with Google, and the Google is going to say, hey, look, this Spotify is trying to access your information. It's trying to access your username and email and so on. Do you want me to authorize it? So if you authorize it here, what it is going to do is, in return, here it is going to give a token. It is going to generate a token, and it is going to give a token here, right? So the music application now has the token. So now it's all done. So what it is going to do in future is, if it wants to access some information, right, it is going to request that information from the provider, right? It is going to say, hey, look, I want this information, and it is also going to give this token, right? This token, whichever it was earlier given, it is going to send that token here, and resource provider will look at the token and he'll be like, okay, I see the token. This was generated when the user authorized it, so I'm gonna allow this. So and it is going to whatever information was requested, it is going to reply back, right, with that information. Right, now you saw in the whole chain here, nowhere the authentication login credentials were exchanged, right? You don't have user and passwords being exchanged. That's the cool thing about the whole OAuth architecture, right? So many SaaS applications use this. The reason is because they don't have to deal with the headache of authentication, right? Or maybe think of a small time business which is I don't know, maybe selling some flowers, right? You have a website you have a SaaS application to sell flowers, right? You're selling flowers online, so you don't want to get into the headache of the manage the money management, right? So what you can do is you can use a OAuth you can use OAuth to some kind of a payment gateway, right? Maybe like Paytm or there are so many there are so many payment gateways out there. So you can use a payment gateway, and then the users will directly authenticate that particular app, and and as a result we'll finish up all the payment stuff, and the gateway will then finally send a call back to your application saying, look, the user has paid the money, you can go and deliver the flowers, right? So this is a very common authentication protocol which is used. Also, it's a very common protocol, yes, and as a result, it is very there are a lot of people who try to use this as attacks as well, OAuth attacks, right? Because what I can do now is, I can kind of create an application which looks very similar to Spotify, but it is not actually Spotify, right? And I can send you an email saying that, look, I have created a new application. It's a pretty cool music app. Do you want to, connect to it? And when you try to connect to it, right, I can ask a bunch of permissions from you, right, using this framework, and you might by mistake even provide me these permissions. Once you provide me these permissions, I can get access to a lot of your information from the resource provider, and I can literally hack it, right? So OAuth is pretty cool. It helps you to scale your SaaS application, but at the same time, it is also prone to a lot of a lot of attacks as well. So you need to be careful while you authorize apps using your resource providers, right? When you do login with Facebook, login with Google, login with Okta, be careful with what you're authorizing, and don't provide malicious apps with all the permissions. Alright, so that was a lot of theory around, because I wanted to give you a clear view about, how the cloud, security works, mainly in a SaaS environment. What is CASB? What is Cisco's solution to it, and stuff like that, right? OAUTH and all of that, right? Now we are going to actually play around with the dashboard of, Cloudlock a little bit to kind of conclude this whole lesson, right? So you can go down to dcloud, right? If you have a valid, account, you can go down to dcloud and you can search for the Cloudlock instant demo lab, right? I'm basically going to be using that. So once you go on that, you can click on the view. It's a instant. You don't even have to reserve and stuff. It's always there. It's more like a read-only kind of a lab. You can't literally do anything with it, but you can just play around with the controls of the dashboard and so on, right? So when you do this, first let's go and install this plugin. You would need this plugin installed for the OAUTH to work, right? So let's quickly go and do that. Just give me a second. Alright, so I've installed the OAUTH plugin. You can see here on the right side, this is the OAUTH plugin. So it's just nothing but a extension, right, which is pretty simple. So once you install it, this is what you get. Now all the cloud apps which are managing using your using your Cloudlock basically will appear here, right? So these are your general public cloud apps, and then you have like WebEx Teams, right? Salesforce, or different vendors, they basically appear here, right? So how do you access the Cloudlock dashboard? So you gotta go to the Cloudlock management console here. So let's look at some very basic use cases here, right? So let's get to that. It's coming up. Okay, so wait a second. Yeah, so looks like it's here. A bunch of things on the top, right? This is the dashboard, right? You can see there are 4 tabs here. The first one is basically your behavioral risk, right? We were talking about the behavior analytics, right? So Cloudlock uses a lot of machine learning and stuff to figure out, if there are some kind of malicious logins happening and stuff like that, right? So these are all your anomalous activities which are happening in your cloud applications, right? This is a demo account, so whatever you see here, data, it's not really literally, it's all cooked up data, but still, this is how the UI looks, right? You can resolve any of this from clicking here, right? If you think that, okay, this is not a serious issue and this is really not, this is like a false positive, probably you can go and resolve it here, all right? So that is mainly your anomaly section. Then you have things around the top users with admin activity, right? That basically appears here. You have your top applications, right? Users and activities. Then you have the geolocation as well. You can see here the locations with highest risk. So you can see a bunch of countries being shown here, and it says that these are the countries from where you're getting a lot of activities which have higher risk, right? Then you have users. You see a bunch of users here, and they are telling that these users have the most login failures happening, right? And compromised account, right? This is very interesting. So this is one thing which I was talking earlier. How does Cloudlock secure users, right? It basically helps you in a way that, let's say you have a user logging in from this say United States, and then within 1 hour he basically goes and there's one more activity coming from Australia. So it clearly means that person would have not traveled so much. So your Cloudlock is intelligent enough to figure out that, okay, obviously these logins which are coming are clearly compromised and they're not actual logins. Then you have data risk. This very much ties to your DLP, right? Data loss prevention. Again, tells you high asset activity, right? It gives you the users, telling that these are the users who are downloading a lot of files or using so many uploading files and so on. And it gives you so this is file download, file deletion, who is doing what, right? All of that information. So you understand how Cloudlock is really helping, right? You're getting a single pane of glass to look at all the cloud related security activity for your organization, right? You can see the various files which are getting downloaded, right? You can click on here and you can even get information as to, you can probably zoom out a little bit and you can see the location from where this is happening, right? You can see the file. This is the particular file which is getting, downloaded, and this is happening from this country, from this IP address, and so on, right? You can also just click go back and it will take you back to the earlier data risk section, right? And these are all self-explanatory dashboards. App risk, right? So this is all tying down to whatever the first one will tell you, will secure your users, second one will secure your data, third one will secure your application itself, right? So here it is telling me that these are some of the applications which I have authorized using OAuth, right? So it basically tells that these are some high risky applications, so I need to be careful of these, maybe because these applications are using some elevated permissions, right? So it is telling me to be careful about these. And then most risky apps, right? You can see that it is also CTR is basically it asks this internal metric using which it is trying to trying to compare which of the apps could be risky, right? So here you can see it is trying to do a peer assessment risk as well. It is trying to tell me that 15 of my apps are trusted by 75 to 100% of peers, whereas there is one app which is not trusted, which is trusted by very less number of people, and I have that enabled as well. So all of that information. So this is mainly like a and then obviously the last one is the policies and the dashboards, right? So which is pretty useful. So we'll talk about policies and incidents in a minute, but this is again giving you like a summary of your incidents and policies which are active right now. It says these are the applications or the platforms which are kind of securing using Cloudlock, right? And tells these are the number of users, these are the number of incidents, and all of that. Like very good summary around your various cloud applications or SaaS applications. Now let's look at some of the examples here. So what we can do is probably let's get to incidents, right? So incidents are basically raised whenever something malicious happens. Now for this purpose, probably we can use a particular incident. Let's go and search for that incident over here. Give me a second. So we can search for this incident and okay, my mouse is not working. Weird. Okay, it's better now. So you can see that particular incident which I filtered out. You can see that incident has a policy attached to it, right? The policy is basically offsite policy. Can I open this in a new tab maybe? Yeah, so you can open a policy, but maybe let's go back here. So it gives you some information here, right? It tells you the platform with which this incident was raised. It's the severity is basically an alert. Offsite activity basically means the use case which I was telling earlier, right? Where you have logins happening from multiple places, right? And that you can basically get from the policy details once we look at the policies. But it also tells us who is the owner of this incident and when it was detected and all of that, right? So if we basically go down to say, let's click on the policy here, right? And you can see here, it basically gives you more information. It's basically telling us alerts of activities performed outside of the main company sites, right? So that's why it's called as an offsite activity. You can see the detection criteria, right? If you edit here, you will basically get the criteria which was set for this policy, right? The platform which it is trying to monitor is Okta, and you can see under countries, the countries where the users are allowed to log into that particular platform is Israel, United Kingdom, and US, right? So looks like someone tried to access this. If you see where was this access coming from, I think it was coming from China, if I'm not wrong, right? So it was coming from China. That's why it was basically raised as a it was raised as a alert, right? So that's something which you can check, and there are other options as well. You can even put a list of trusted IPs. So you can put a list of trusted IP, and that way your Cloudlock will not even monitor that connection, because it knows that that particular IP is a trusted, so it doesn't have to worry. You can also put a list of risky IPs, so that whenever it gets a connection, whenever it sees that someone from that risky IP is trying to connect to it, then it's more like a blacklisted IP, right? So it is going to disconnect from that session, right? And it's not going to allow, it's going to block that particular user. So you can put such kind of cool policies, right? And let's go back to that let's click on this incident, and we can see that you see the location from where the access was coming. It was Shanghai, China, and that's why this particular incident was raised, right? So that's a very good use case for how Cloudlock is kind of securing the users, right? The second thing is probably we can check Do I have another use case here? Give me a second. Yeah, so probably we can check for DLP maybe. Give me a second. Yeah, so let's go back to this incidents dashboard, and here let's put in the incident number again, and a different incident number, right? And you can see here this is a use case mainly for the how Cloudlock is securing your data, right? So you can see here looks like someone has shared. You can see the policy. It says publicly shared. So it looks like someone has shared some important document in box, right? Which you're not supposed to do, right? You can click on this policy and you can see information about the policy. You can see data exposure, and that's why it is raining a warning, right? You can edit here and you can see the platform is box, the file type, it is tracking all the files, right? File size, ownership, exposure, right? And under exposure, under box, you can see they have enabled this policy where whenever you try to share share a particular project or document or any type of file with external users, right, with a public link, immediately alert is going to be raised, right? So this is very useful because now this alert will be sent to the IT admin and as well as the user so that they can quickly remediate this issue, right? So that's how Cloudlock helps you and kind of secures your data on the SaaS application, right? So we have secured the user, we have secured the data, and the last one, probably let's quickly look at how we are securing applications as well, right? So let's probably quickly look at another use or another incident here. These are all, like I said, these are all like a you read-only dashboard, so you can't really build any new policies, I guess. It's pretty good for you to just get used to the UI and the dashboard part, right? So we are looking at another incident here where it looks like we are dealing with Office 365, right? It's an Office 365 issue, and let's click on this policy and see what is happening here. Okay, so what is happening here is apps whose authorized access scopes present potential security risks. Okay, so what has happened is some user has authorized a third-party app, right, to use Office 365, and looks like that particular app is using a lot of is basically using a lot of permissions from Office 365, right? So that's why it is getting classified, and we can even look more details by clicking on that particular incident. And you can see here at the bottom, so these are all the permissions which that particular app is trying to do, right? It is trying to access the let's probably click on the right side. Yeah, it's trying to read the basic profile, it is trying to read the email address, it is trying to access users data, it is trying to delete files and all of that. So looks like it's a malicious app, right, which the user has authenticated using OAuth, right, to its Office 365 platform, and as a result, now that particular application seems to have, this application is called what, Kaizina. So this particular application seems to have a lot of elevated privileges, and as a result, it can cause drastic repercussions to that particular enterprise's Office 365. So that warning is also raised. So now you can basically make a collective decision on what you want to do with this. You can probably block this application, you can immediately remediate it, right? So that's how, right, that's basically what you see here. You have a basic dashboard, but then the very important crux of the whole Cloudlock, basically you see it over here in the policies section, because here you can go and write, you can remove this filter, right, and you can see a lot of policies here, right? These are all the pre-built policies. You can create your own custom policies, right, as well, and in each of the policy you can define what is the detection criteria and what is the response action, right? What do you want Cloudlock to do? Do you want an alert message? Do you want an email? Do you want the user to be blocked? Do you want the user to be quarantined, right? All of that can be defined, right? So that is pretty cool. And activities is basically nothing but a list of activities for the IT admins to continuously monitor, right? Whenever there is a data upload, data download, whenever there is a authentication happening, all of that gets logged there, right? If I remove these filters, clear filters, you'll basically see a bunch of, you can see all this activities which are happening in your whole cloud infra, right? So that's mainly Cloudlock, guys. It's a single pane of glass to kind of I would say single pane of glass to do those 3 points which I talked about, right? Behavior analytics, DLP, and application firewall, right? So do all of those in a single pane of glass to track all your cloud applications, right, in one single place. I think this is a very good cool solution to do that, right? So hope that was useful, and have a good one. Bye, guys.